Hello everyone! Today we're going to be covering the Whiskermania Intro to Network Concepts game from KC7. To learn more information about the game, the difficulty is challenging, duration is 8 hours and 59 minutes, level required is 9, and players is 820. Also, there's a really helpful feature associated with this game and much more that will be covered. So the first one is report issue, so if you click on it. So what report issue does is that you can report any issue that you're having with the game, whether it's something that is broken, wrong or confusing content, layout or display problem, or other, and then you can state what happened, and then you can also do the captcha as well. However, please do not include passwords or other sensitive info, please. You're doing that. And overall, once you click on the send report button, you will send this information to a member on the KC7 team, and we will be more than happy to look at this issue and get it addressed. So overall, if you guys have any issues throughout this game, you're more than happy to report them. We'll look at them and overall improve the quality of this game, so that way you can focus on learning instead of having to deal with the bugs, because we would have addressed them. So with that being said, let's talk about the game itself. About this game, you just got hired as the IT administrator at a cat sanctuary, which would be great news if you had any idea what you were doing. By following Jamie's trail and asking the right questions, you will learn how networks actually work, whether it is IP addresses, VLANs, virtual local area networks, firewalls, ports or protocols, and DNS, domain name service. Overall, this is a fun and data-driven take on a classic networks class. So if you wanted to brush up on your computer networking fundamental concepts like IP addresses, VLANs, firewalls, ports, protocols, and DNS, or you're just starting out on your cybersecurity journey and just getting first exposed to computer networking, this is a really great game, and that's why I chose it, because computer networking is very important to understand. So in this game, we're going to learn about computer networking concepts, which can be found in learning objectives, and overall, we're going to have fun learning about computer networking concepts. So that being said, since it's a game, let's start playing. And also, in this part, shout out to the contributors of the game. They're the ones who contributed to making this game, so all credit goes to them. Requirements: no prior experience required. Just willingness to fake it until you make it. And also, if you wanted to share this module so that way you can get more players playing this game, you can share it on Twitter, LinkedIn, or you can email it. But yes, and here is the really awesome image as well. Here is an image of a cat, the switch, Whiskermania, Intro to Networking Concepts. So that being said, let's get started. And for transparency reasons, I've already completed this room, but I'm going to show you a really great feature that allows us to play this game completely from scratch. So let's play again. And that helpful feature is we can replay this game. So let's click on that. Alright, so what replay this game does is that we are starting completely from scratch. None of the questions have been answered for each of these sections. So overall, we're starting from the very beginning and redoing this game. However, if you do replay mode, scores in progress will not be saved. But for learning purposes, I just wanted to show you guys that. So that being said, let's get started. In section 1, which is Welcome to the Chaos. And it has 3 questions. Let's do this. Your badge says IT Administrator. Your stomach says, I have a terrible mistake. You step through the front door of Risker's and Wonder's Cat Sanctuary and immediately have to sidestep a kitten. Then another. Someone rushes past with a carrier, a phone is ringing somewhere, and a cat is yelling from the back room. Morgan Chen, the operations manager, spots you from across the lobby. They're holding a clipboard, a coffee cup, and somehow also a cat. Oh, thank God. You're the new IT person. Jamie's replacement. You nod confidently. You definitely know what you're doing. Morgan doesn't look entirely convinced, but they're too busy to dig deeper. Great. I'll get you orientated once I deal with this. The cat in their arms makes a break for it. Morgan catches it. Kitten season. They explain as if that covers everything. So that being said, that's type definitely ready to continue. However, there is a couple other really helpful features that I want to highlight. The first one is analyst notes. So what analyst notes does is that it provides you better information to help you better understand the game. So if you just wanted more clarification and overall better understanding of the concepts pertaining to a certain question, click on analysis notes and that's going to help you out. So pertaining to this question, the analysis notes is that kitten season is a real phenomenon in animal shelters. It typically runs from April through October when unspayed cats give birth to litters. Shelters become overwhelmed during this period, often operating at 230-300% normal intake capacity. This creates exactly the kind of organizational chaos that makes security incidents harder to notice. Now there's another really helpful feature called Stuck. That's the question. So what this does is that if you have Discord, but if you don't, and this is your first time learning about Discord, don't worry. Discord is a free chat program where the KC7 community gathers to help each other learn cybersecurity. When you get stuck on a question, you can ask real humans for assistance. Our volunteers and experienced players are there to help you. So what you'll find is a helpful community. You can get guidance from experienced players, game-specific channels, such as, for example, we have a channel for Whiskermania. You can discuss challenges with others working on the same game, learning resources. We have tips, tricks, and cybersecurity knowledge sharing, and events and announcements. You can stay updated on new games and features. However, and this is very important to note, is that you must be 13 years or older to use Discord. If you're under 13, please ask a parent or guardian to help you. So if you want to join the KC7 community, please do, and we'll be more than happy to help you out if you have any questions or concerns pertaining to these games. Or if you just want to talk about cybersecurity in general and get more assistance with that, you can join the community here, join Discord, and we'll be more than happy to help you out. So that being said, let's type definitely ready. Nice. All right. Question 2. Morgan leads you through the shelter, dodging volunteers and explaining things at high speed. Intake area, medical wing, adoption center, a room full of kittens that makes you stop for a moment because, well, kittens. Whiskermania is in 5 days, Morgan says, and you can hear the stress in their voice. Our biggest fundraiser of the year. Last year we raised $40,000 in 1 day. Lots of donors, lots of web traffic, lots of things that need to not break. They glance at you. Jamie was supposed to handle the tech side, but then Jamie left, and they trail off. You're starting to understand why they hired you so quickly. So let's type no pressure to continue. If you want to click on the analyst notes here, here is the information. This is a story checkpoint where Morgan is giving you a tour of the shelter. The answer is a phrase expressing reassurance about not having to remember everything. In this case, the answer is no pressure. Alright, question 3. Morgan stops at a desk in the back office. It's still set up with someone else's stuff. A cat-shaped mug with cold coffee, post-it notes stuck to a monitor, and a notebook lying open. This was Jamie's desk, Morgan says quietly. They left about 2 weeks ago. Kind of suddenly, didn't really explain why. They look uncomfortable. We haven't had time to clean up. A large orange cat is asleep on the server rack in the corner. That's Biscuits, Morgan adds. He comes with the office. Non-negotiable. You sit down carefully, trying not to disturb anything. One poster catches your eye. Every device has an address. You learn the addresses. You learn the network. Seems like good advice, and you're going to need it. So let's type, let's learn to continue. And here's the analyst notes here. I'm not going to read all of it, but the one thing that I want you guys to get from this is that the notes and artifacts they leave is that, well, actually 2 things. When an employee leaves suddenly, especially one with IT or security responsibilities. It's a red flag worth investigating. And the notes and artifacts they leave behind can provide valuable context for understanding the state of their network. Got it? Type listen. Nice. Alright, on to section 2. Section 2 is the network map. As you can see, it has 19 questions. But don't worry, we got this. So let's start with question 1. Let's start with the basics. You need to look like you know what you're doing, which means exactly knowing what you're doing. An IP address is like a mailing address for computers. Every device on your network needs one so other devices know where to send data. The format looks like this. You have 4 numbers. You have 10, 10, 16, and 5, and they're separated by dots. You can see that there's 1 dot separating the 10 and the 10, 1 dot separating the 10 and 16, another dot separating the 16 and the 5. Each number, which you can see here, there's 4 of them, ranges from 0 to 255. There you go. You'll see IP addresses constantly in network network logs, not eggnog, logs, how you identify which device did what. So what does IP stand for? So let's look at our analyst notes. We have a hint. Awesome. IP, or Internet Protocol, is a fundamental protocol for routing packets across networks. Additionally, IP version 6 uses 128-bit addresses to solve this limitation, which is the amount of unique addresses for IP version 4. But unfortunately now, that number is insufficient for the modern internet. Thus, IP version 6 uses 120-bit addresses to solve this limitation, but IP version 4 remains dominant in internal networks. So now we have that information. Our answer is going to be internet. Spell internet protocol. Awesome. Alright. IP version 4 addresses have 4 numbers separated by dots. Each number here is called an octet because it represents 8 bits of data, and 8 bits can represent values from 0 to 255. So 10.10.16.5 has 4 octets because there's 4 numbers, 10, 10, 16, and 5. So that information, how many octets are an IP version 4 address? So this is our IP version 4 address, and we need to figure out how many octets are in this address. Since we have 4 numbers, we have 4 octets. Because each number is called an octet because it represents 8 bits of data, and 8 bits can represent values from 0 to 255. Go for it. Awesome. And here's our analyst notes here. So, pertaining to this, the term octet literally means group of 8. Each octet is 8 bits. So, an IP version 4 address is 32 bits total. We have 4 numbers. You have 4 octets. They're each 8 bits each. So, 4 times 8 equals 32. But also, the maximum value of an octet is 255 because that's the largest number you can represent with 8 bits. 2 to the 8th minus 1 equals 255. So when you see an IP address like 192.168.1.1, you're looking at a human readable representation of a 32-bit binary number. Awesome. Alright, section 2, question 3. Morgan walks by your desk. You're getting orientated. The network here is pretty straightforward. We use private IP addresses internally. Private addresses, repeat, loud and wisely. You have no idea what that means, but you're not about to admit that. Here's what you need to know. Certain IP ranges are reserved for internal networks and can't be reached directly from the internet. These are called private IP addresses. So, to break this down, first one, 10.0.0.0 to 10.255.255.255. Anything starting with 10 is our first private IP range. 172.16.0 to 172.31.255.255. 172.16 through 172.31 as our second private IP address range. And finally, 192.168.0.0 to 192.168.255.255. Anything starting with 192.168. Anything outside of that range is considered to be public, meaning it's routable on the internet. So, pertaining to our question, is 10.10.16.5 a public, or is it a private IP address? In this case, since this IP address starts with 10, and anything starting with 10 is going to be considered a private IP address range, we're going to answer with private. Awesome. And this is our analyst notes. Like I said, and to take from this, and the important thing to mention and to take note is that the three private ranges offer different sizes. 10.x.x.x provides around 16.7 million addresses. 172.16 to 31.x.x provides 1 million. And 192.168.x.x provides around 65,000. Most home networks use 192.168.x.x. Enterprises, on the other hand, they typically use 10.x.x.x. Got it. Nice. All right. For this question, 8.8.8.8 is Google's public DNS server. It doesn't start with 10. It's not in the 172.16-31 range. And it's not 192.168. So it's not private. So pertaining to our question, is 8.8.8.8 public or is it private? Since it's not in our private IP address ranges, it's going to be considered public. Answer public. And here's our analyst notes here. Such as, for example, Google operates 8.8.8.8 and 8.8.4.4 as free public DNS resolvers. Cloudflare operates 1.1.1.1. And these are useful to know because they're commonly used as external connectivity tests. If a device can reach 8.8.8.8, it has internet access, and you'll often see these IPs in DNS configurations and troubleshooting. Awesome. Alright. 192.168.1.1 is a common home router address. Is it public or is it private? We're going to say private because 192.168.x.x, or in this case 192.168.1.1, falls in the 192.168.x.x private IP address range. Right? Alright. This one. 172.20.50.1. The private range for 172 is 172.16 through 172.31. This is 172.20, which falls in that range. Is it public or is it private? It's going to be private in this case. And here's our analyst notes here, which is very important to understand. I'm not going to read through all of this, but just know that the 172.16-31.x.x range is the trickiest to remember because it's not a clear boundary. So, because of that, 172.15.1.1 would be public, but 172.16.1.1 is private. Because only 172.16.0.0 through 172.31.255.255 is private. And so if you're studying a certification exam such as like CCNA or Network Plus, hopefully that helps you out distinguish the difference. Alright. 52.214.98.1 is an AWS cloud server. 52 isn't any private range. Is it public or is it private? We're going to say public. But also I want to show you guys a really helpful IP lookup website. So we're going to take this IP. We're going to go here. We're going to IP info. We're going to type here. Yes. So what this website does is that it provides you really helpful information pertaining to an IP. So we were talking about an AWS server. We can see here that AWS is mentioned. Also, we can see the IP geolocation, anonymization, ASN. So this does belong to Amazon and much more. So overall, if you wanted to use an IP lookup website for your investigations or check an IP for more information, this website does a really great job of providing you a really great summary, geolocation, anonymization, ASN, company, and abuse as well. Hopefully you all find this useful. Moving on. Now, so we have our analyst notes here as well that you can click on this. And the one thing I want to note is that knowing that 52.x.x belongs to AWS can be useful context during an investigation. Nice. All right. Question 8. You find another of Jamie's post-it notes stuck to the side of the monitor, 185.174.30.137.42. Who is this? Check again. The handwriting gets more urgent toward the end. Jamie circled the IP twice. Is 185.174.137.42 public, or is it private? Since it doesn't fall into our private IP ranges, we're going to say it's public. Nice. And we can look at our analyst notes here as well. And one helpful tip is that tools like Whois, IP geolocation services, and threat intelligence platforms can help identify who owns an IP and whether it has a malicious reputation. Awesome. All right, question 9. You pocket Jamie's note. That IP might be important later. Morgan pulls up a network diagram on the whiteboard and grabs a marker. Let me show you how we got things set up. We split our network into zones. For different zones, for different purposes, it's called network segmentation. So pertaining to our question, how many VLANs or network zones does Whiskers and Wonders have? And we also have a grateful tip as well. If you see the question mark, it's going to be a hint. So in this case, it's count the unique VLANs. So we're going to type, or you can copy the, paste, yes. There you go. You can paste the query. Let me break it down. We're using the device info table. So let me talk about those. So you can hover over about data, click on view data tables. And here it's going to show you all the tables associated with this game. So if you wanted to get a better understanding of a certain table for a certain game, the available tables does a really great job of that, because it not only tells you what the name of the table is, but also a description of it as well. In the columns associated with it, such as, for example, say that we wanted to learn more about the authentication events table. It records successful and failed logins to devices on the company network, and this includes logins to the company's mail server. There's columns also associated with this table, such as timestamp, host name, source IP, user agent, username, result, password hash, and description. So if you wanted to learn more about a certain table, a description of it, any columns is provided as well. So hopefully you guys find this useful. But also, if you wanted to query the data or switch to classic ADX in terms of view, you can do that as well. And if you wanted to get more room to do your query and not see the questions, you can click on this. And now you have more room to do your query. And if you wanted to see the questions, you can either click on the arrows or click here. So let's click on the arrows. Now you have access to see your questions. So that being said, what this query does is that we use the device info table. Then we create a column called device count, and we count the devices by VLAN, and then we order the number of devices for each VLAN by descending order. So that's going to be the largest number first, all the way down to the lowest or smallest number. So if we highlight this and we run it, we're going to see our different VLANs and also our device counts as well. So in this case, how many VLANs or network zones does Whiskers and Wonders have? We can see here that there's 5 VLANs. So let's check our answer. It's going to be 5. Nice. Also, there's an analyst notes here as well that you can read for more information to help you better answer this question. Awesome. Alright, Morgan sketches the network layout. We have the internet, we have a router, we have a firewall. You see that there's 3 networks. There's a DMZ, there's a restricted, and servers. Actually 4. Workstations, there we go. We have our switch. Then we have our web, mail, and DNS servers. We have our proxy, databases, and app servers here. And we have our domain controller. So this is our network layout. And each zone has its own IP range. Morgan explains, if I see 10.10.16.x, it's associated with workstations. And I know it's a workstation. 10.10.0.x means DMZ. And the IP tells you where the device lives. So we're going to use this query again to figure out which VLAN has the most devices. So let's look at the first row, because we ran our query that's associated with this question earlier. And we can see that the VLAN that has the most devices is going to be workstations. And if you wanted to use the analyst notes for this question, you can see here, here's a text version of the diagram as well. So not only do we have an image version, we also have a text version of the diagram as well. So help you better understand the network layout and overall network diagram. Awesome. Click on workstations. Now, question 11 of section 2. The DMZ or demilitarized zone bases the internet. It contains systems that the outside world needs to reach. Web servers, the donation portal, VPN gateway. This is where Whiskermania traffic will hit. Morgan says lots of donors visiting the site, making donations. It all comes through here. So we have a query. It's called device info where VLAN equals DMZ. So we're dealing with the DMZ VLAN. And we want to output only the name, IP address, and host type rows. There we go. And columns. There we go. So what is the IP address of the donation portal? So the donation portal we can see here under name, and the IP address associated with it is going to be 10.10.0.3. So it's going to be 10.10.0.3. Awesome. And analyst notes. Here you go. Awesome. All right. The DMZ is a network segment that sits between the public internet and the private internal network. It's called demilitarized by analogy to military buffer zones, and for defensive, for defenders. This design ensures that if a DMZ is compromised, the attacker doesn't immediately have access to internal systems. It's very important to understand. All right, next. Question 12. Where an expression gets serious. The donation portal is critical. We're a nonprofit. Every donation matters. And Whiskermania is when most of them come in. They paused. James seemed really stressed about the donation system before they left. Kept asking questions about traffic to it. I thought they were just being thorough. So we're going to use device info where VLAN equals server. So now that we're dealing with the server's VLAN, if I can spell correctly, project, name, and IP address. We have to copy the query as well. Let's run this. Nice. So what is the IP address of mail server 01? We can see here under name, mail server 01, and the IP address is going to be 10.10.1.2. 10.10.1.2. Nice. All right. Question 13. Morgan lowers their voice, and the restricted zone is where we keep the domain controller. It handles all authentication for the network. If someone compromises that, game over. So I'm going to use this query, device info, where VLAN equals restricted. So we're using the restricted VLAN, and we want to understand the name, IP address, and host type as our output, and any data associated with those fields as our output as well. So we have our name, IP address, and host type. Now, so we can see the data type as well is strings, and we see that there's a domain, the domain controller, IP address for it, and the host type is a server. So what device is in the restricted zone? It's going to be domain controller. Nice. All right. You're starting to see the pattern. Each VLAN has its own IP range. We got DMZ, it's 10.10.0.x. Servers, it's 10.10.1.x. Restricted, 10.10.2.x. And for workstations, it's 10.10.16.x. This means you can look at any IP and immediately know what part of the network it's in. For example, we're going to use this query, which is device info, here, where IP address starts with 10.10.1. We're going to output the name, IP address, and VLAN field such as here, and we're going to take 5. What take means is that we're only going to output 5. So we're going to only see 5 records. If we run this, there you go, 5 records. And pertaining to our question, what VLAN do IPs starting with 10.10.1 belong to? So we can see here we have a bunch of names, IP addresses, and all of them are in the server VLAN. But we want to understand what VLAN do IPs starting with 10.10.1 belong to. So we can see each VLAN here. We have 4 of them: DMZ, servers, restricted, and workstations. And the one that starting with 10.10.1 is going to be servers. So that's it. So let's put that as our answer. Nice. And we have our analyst notes here as well. Awesome. Alright. Question 15. So if I see an IP starting with 10.10.0, you say, I know it's in the DMZ. Exactly. Morgan looks pleased that you're catching on, and 10.10.16 means workstations. 10.10.2 means restricted. So once you know the ranges, you can read the network like a map. So what IP range are workstations in? Format 10.10.x. We have that. So it's going to be 10, not 110, 10.10.16. Nice. All right. Here is our query that we're going to use. So let's copy that. Paste. So DNS is how computers translate domain names like google.com into IP addresses. For instance, when you type a website name, your computer asks the DNS server what's the IP for this and gets an answer. Every lookup on the network starts here. So pertaining to this, what is the IP address of the DNS server? So we're going to take this query and we're going to run it. Only 1 second. HTTP 400. It looks like we're having errors. But don't worry. We're going to refresh and we're going to resolve this. I call this troubleshooting. Bam! Let's go to section 2. Let's go to 16. And now we've got our IP address for this DNS server. It's going to be 10.10.1.7. 1.7. Nice. Analyst notes here as well. And for security analysts, DNS is invaluable because almost all network activity begins with a DNS lookup. Even if subsequent traffic is encrypted, the DNS query often reveals the destination in plain text. So, question 17. You dig through Jamie's desk drawer and find more notes. IP addresses everywhere, some circled, some crossed out. One note says internal DNS, 10.10.1.7, all queries go here first. Another note crumbled like Jamie, threw it away and then fished it back out. Why is 10.10.16.x talking to 185.174.137.42? That's not normal. Jamie was tracking traffic from workstations to an external IP. They thought something was wrong. So for this question, we want to understand what table would show you DNS lookups. So we're going to look for a table with DNS in the name. So we're going to go to About Tables. We're going to try to find DNS lookups. And as we see here, for DNS events, it records DNS lookups made by clients on the computer network, including the query name and type, the resolving server, the response code, and the IPs returned. So we're going to try DNS events as the answer. Booyah. Next. The firewall sits between network zones and controls what traffic can pass between them. Think of it as a security checkpoint that inspects every connection and decides whether to allow or block it. Traffic between zones has to pass through the firewall. Morgan explains that's how we control what goes there. Workstations can reach the internet, but the internet can't reach workstations directly. You find another node, check firewall logs, something is getting through that shouldn't. So what zone contains the domain controller? So we use a query, this one, device where VLAN equals restricted. So we're using the restricted VLAN. You run. And we can see for that zone or VLAN that the domain controller shows up. So our answer is going to be restricted. Nice. All right. And here's our analyst notes here to help you better understand firewalls. So here's two things I want you to know from this analyst note is that firewalls operate on rules that specify which traffic to allow or deny based on source IP, destination IP, port, and protocol. Additionally, firewall logs are essential for security investigations because they record both allowed and denied traffic, showing what succeeded and what was blocked. Let's go to question 19. Alright, you lean back in Jamie's server. Biscuits has migrated from the server rack to the desk and is now sitting on a pile of papers, watching you with mild interest. Private IPs for internal use, public IPs for the internet, VLANs segmented network, IP ranges to identify zones. You're starting to see how the pieces fit together. Nice. Morgan gets called away to deal with a kidney emergency. You're alone with Jamie's notes and a lot of questions. So we continue. Let's type. Time to dig deeper. And now we're on to section 3. Following the trail, it has 26 questions. So let's get started. We got this. All right. Question 1 of section 3. With Morgan gone, you have time to dig into Jamie's notebook properly. There's a page titled Network Flow Analysis with a note at the top. Every connection has two endpoints. You have a source IP plus port that goes to destination IP plus port. So you know about IP addresses now, but what's a port? Think of it this way. The IP address gets you to the right building, but the port gets you to the specific apartment. A server might run multiple services, and each service listens on a different port. So we can see here that we have a server running multiple services, which are SSH, HTTP, and HTTPS. And each of them listen on different ports. So we have 22 for SSH, 80 for HTTP, and 443 for HTTPS. And also port numbers range from 0 to 65, 535. So with that being said, what is the maximum port number? It's going to be 65,535. That's going to be our answer. Awesome. And we have our analyst notes here to help you better understand what ports are as well. Alright. Certain ports are standardized. You'll see these constantly. We have 22 for SSH, 25 for SMTP, send an email, 53 for DNS, domain name lookups, 80 for HTTP, unencrypted web traffic, 443 for HTTPS, encrypted web traffic, and we have 3389 for RDP, Windows Remote Desktop. You memorize these because when you see a connection on port 443, you know it's HTTPS. When you see port 22, someone is using SSH. So for this question, we are asked what port number is used for HTTPS. And we can see that the port number is 443, and it's for HTTPS encrypted web traffic. So we're going to put that as our answer, 443. E. And our analyst notes here as well. So for unencrypted HTTP is port 80, but for port 443, that's the encrypted version, because we can see here, when analyzing network traffic, seeing port 443 tells you that the content is encrypted, but you can still see the source IP, destination IP, now to the domain name via SNI, server name indication without decryption. Awesome. So what port number is used for DNS? It's going to be 53. Booyah. What port number is used for SSH? 22. And also, I really like the positive, encouragement messages when you get a question right. That is awesome. So what port number is used for RDP? We have an analyst note here to help you out. And it's port 3389. And it's important to know, remote desktop protocol on port 3389 is a common target for attackers, because seeing unexpected RDP connections, especially from external IPs, is a significant red flag, because many ransomware attackers begin with compromised RDP credentials. All right, next. Let's see what ports are most common on this network. So we're going to use the network flow table. So we're going to do this. We're going to paste. We're going to create a traffic column here. And we're going to order by traffic descending order. So the biggest number to the smallest. And we're going to take 5. So we should only see 5 records by destination port. So for each, so what this query is going to do when we run it is that it's going to show us the destination ports associated with this table, and it's going to show us the traffic in terms of count for each one of these ports from the biggest number to the smallest, because we're ordering by descending order. So what destination port has the most traffic? It's going to be 25, because it has the largest number compared to the other ones. So it's going to be 25. Nice. All right, so port 25 is SMTP, which handles email transmission. High email traffic is expected for an organization that communicates regularly with donors, adopters, and volunteers. But what does SMTP stand for? We have an analyst note. It stands for Simple Mail Transfer Protocol, and it's used for sending email. And you can read more about this here. But there's one other thing that I want you guys to understand is different protocols, POP3, IMAP, in their encrypted variants, ports 995 and 993, 995 for POP3 and 993 for IMAP. And email is a critical attack vector. Most phishing campaigns use email as their initial access vector, so it's going to be Simple Mail Transfer Protocol. Awesome. All right, question 8. Jamie's notebook has a section on protocols. There are 2 main ways data moves on a network. We have TCP, which is stands for Transmission Control Protocol. It's reliable and it's ordered. It establishes a connection first, a handshake. It confirms delivery and resends anything that gets lost. And most traffic uses TCP, whether you're web browsing, email, or doing file transfers. UDP, on the other hand, is fast, but it's unreliable. It just sends packets without confirming they've arrived. This is fine for things like DNS lookups or video streaming, where speed matters more than perfection. So, what does TCP stand for? We can see here, the TCP stands for Transmission Control Protocol, and it's reliable and ordered because it establishes the connection first, which is a handshake. It confirms delivery and resends anything that gets lost. Transmission Control Protocol. Nice. Alright. What does UDP stand for? So in the previous question, we saw that it was User Datagram Protocol. If we can spell correctly, it's datagram. Nice. Alright. And here, analyst note here. And UDP is to help you better understand UDP more in depth. But to know from this, attackers sometimes use UDP for exfiltration because some networks monitor TCP more closely. Nice. All right. We're going to still use our network flow table. We're destination port equals 53. So now we're looking at DNS traffic in our network flow. And we're going to summarize the count by protocol. So, what protocol does DNS primarily use? We can see that the protocol is UDP, and we can see the count, and we don't see that there's a mention of TCP, so our answer is going to be UDP, and we have a hint. Run the query. We did. Awesome. We have an analyst note here as well to help you better understand DNS. Yippee. Alright. Next. Network flow. We're going to use this query. Summarize count by protocol. Order by count descending. So, what protocol carries the majority of network traffic on this network? So, if we run this query, and guess I have hip. Run the query. I love these hints. You're so direct. Awesome. Alright, TCP and UDP. So which protocol carries the majority of network traffic on this network? We can see here that TCP has a much larger number than UDP. So our answer is going to be TCP. Yep. Alright. Morgan pokes their head back in. Still alive in there? Does reviewing the network architecture you say, which is technically true? Morgan doesn't look entirely convinced, but they're too busy to press. Holler if you need anything. I'll be dealing with the new kid in intake. Biscuit's still on the desk. Yawns. So we can type, it's totally normal. To continue. Totally. Nice. Alright. Now for the key insight that ties everything together. DNS. When you type a website name into your browser, your computer doesn't actually know where that website lives. It has to ask. It sends a query to the DNS server saying, what's the IP address for google.com? And the DNS server responds with answer. So you can see here, we send a query to the DNS server asking for the IP for google.com. And then the DNS server responds with that IP, which is 142.250.80.46. Go with it. And that is how DNS works. From a high level perspective. But just from like a foundational perspective, this is how DNS works. So, for this question, what does DNS stand for? And also to note, this happens before any actual connection. DNS is the first step. So it's going to be domain name service. Domain name service. Why am I going to... Oh. Alright. Domain name service. When you query, and yes, this is to understand DNS more in depth. And for security analysts, DNS logs are gold. The reason why is because they show intent before action, and they're rarely encrypted. Though DNS over HTTPS is changing this. Okay, this isn't right. Excuse me. Okay, I said see this. Alright. Domain name service. Let me see if I get something. Domain name. Oh, let me see if this question is asking for domain name service. Let's see if it wants lowercase. Or is it domain name server? DNS. Let's look it up. Let's use trusty Google. And what is DNS? Domain name system. I was close. I had the first two. Domain name system. Awesome. Alright. Next question. We're going to use the DNS events table. We're going to run this query. Let me just do. Oh, no. Oh. Let me give you this. Let's look at this. There we go. Paste. Alright. So what we're going to do is that we're going to use DNS events table. So what is the DNS events table? Well, the DNS events table logs every DNS lookup on the network. You can see which device asks what domain they talked about and what IP address was returned. So what column contains the domain name that was looked up? So we're going to run this query. We have columns, we have timestamp, we have client IP, we have query name, result IPs, and DNS server. And we can see here that for our output, that the column that contains the domain name that was looked up was query name. So we're going to use that. So query name. Alright. DNS records come in different types. We have an A record. So an A record maps a domain to an IP version for address. Google.com 242.250.80.46, for example. We have also AAAA, 4 A's. We have record, that maps the domain to an IP version 6 address. And then we have an MX record that identifies the mail server for a domain. And also we have a CNAME record, which creates an alias pointing to another domain. So what type of DNS record maps a domain to an IP version address? It's going to be an A record. Awesome. We have our query here to learn more about other DNS record types. And one thing to note is that security analysts often check TXT records or text strings for SPF DMARC configurations is associated with email and PTR records to see if an IP has a legitimate reverse DNS entry. Awesome. Alright, so now we're moving on to question 16. We're going to run the scanning. So we have the output. So TTL. Time to live tells the client how long to cache the result before asking again. A TTL of 300 means remember this answer for 300 sections. So pertaining to our question, what does TTL stand for? It stands for time to live. And we have our analyst notes here to help you better understand how attackers use TTL. Awesome. Nice. You're starting to understand why Jamie's notes kept mentioning DNS. If malware needs to connect an attacker server, it has to look up the address first. That lookup gets logged. DNS is a record of intent. You can see what domains a device tried to reach, even if the connection itself was encrypted. So, Jamie wrote, check DNS again. The answer is in the lookups. So we're going to type following the breadcrumbs to continue. Your analyst notes here as well. Important to understand is that there's two things. This principle is fundamental to network security. Even if when traffic content is encrypted, metadata remains visible. And this is why organizations log DNS, proxy, and network flow data, even though they can't see inside encrypted sessions, because metadata provides you really helpful information. Click submit. All right, let's trace how a single web request moves through the network. When someone browses to a website, multiple things happen in sequence, and each step creates a log entry. So you can see here we have a diagram showing the workstation, DNS, and proxy, and we can see that there is a certain exchange going on, certain steps. So let's break this down. First, the DNS lookup log in DNS events, then the network connection, which we can see here. Then the proxy processes it in proxy events. Using the proxy, you can see that information in the proxy events table. Then one user action multiple log entries. So overall, if you wanted to better understand how a single web request works, is that first you have the DNS lookup, which is logged in the DNS events table. Then the network connection, which you can see that information in the network flow table. Then the proxy processes it, and then you can see that information in the proxy events. So overall, you have one user action, which is someone browsing to a website, but there's multiple log entries. So let's trace a real request. Someone browsed to docs.google.com. So let's use this query, which is associated with the DNS events table. And it has our timestamp, client IP, query name, and resolved IP. So pertaining to this, we also have a hint. Run the query. I love these hints. For analyst notes here. This multi-stage login is why correlation is essential for investigations. For instance, a single user action might generate 5 to 10 log entries across different systems. Thus, time synchronization, or NTP, across all systems is essential for accurate correlation. Yes, it is. So what IP address did docs.google.com resolve to? We can see that it's 152.52.146.99. 52.146.99. That's our IP. Awesome. And we have our analyst notes here if you want to check it out, which I covered. Nice. All right, so question 19. Step 1 complete. DNS resolved docs.google.com to 152.52.146.99. Now let's see the network flow for that DNS query. DNS uses port 53. So when the user with IP address 10.10.16.14 conducts a DNS query, we can observe some corresponding traffic to the DNS server over port 53 around the same time. So let me use this query. I'm going to break it down because it's starting to look very comprehensive. So let's run this query. I knew the hint was run the query. Oh, that's awesome. And so what protocol was the DNS query using? So let me break down this query. So we're using the network flow table. We're looking for a source IP that is 10.10.16.14. And we're searching between June 3rd, 2025 from 8:39:19 a.m. to 8:59:19 a.m. It's the same day. we're just looking for any events between 8:39:19 a.m. to 8:59.19 a.m. on June 3rd, 2025. We're also looking for the destination port 53, and we're outputting the timestamp, source IP, destination port, and protocol columns, and we're limiting the results to 10, which is the maximum amount of results that we want. So pertaining to this, what protocol was this DNS query using? You can see it's UDP. Nice. So after DNS resolved the domain, the computer connected to the destination IP on port 443 for HTTPS. So we're going to use this query. So we're looking for a source IP. As you can see here, we have our destination IP, and we have our project timestamp. We're outputting the timestamp, source IP, destination port, and protocol. We're only taking one result. So our maximum amount of records should be 1. Nice. So what destination port was used for the HTTPS connection? Let me guess, the hint is run the query. I knew it. So what destination port was used for the HTTPS connection? 443. Our answer. And the proxy sits between internal users and the internet. It logs the full URL of every web request, even for HTTPS traffic. The shelter does SSL inspection. So we're transitioning to now from the network flow event table, from the network flow table to the proxy events table. We're still looking for a source IP of 10.10 to 16.14 and the domain docs.google.com, but we're looking at a different timestamp range, such as we're still looking on June 3rd, 2025, but we're looking at 8:50 to 9, and it's not specified whether it's AM or PM, but just know that we're looking at a different timestamp range, and we only want to take one result. So, what HTTP status code was returned? It's going to be 200, and if you are just getting exposed to status codes, don't worry. Let me help you out. So AI mode. I know. I was looking at what could you please break down the different HTTP status codes, please? There we go. So overview of HTTP status codes. HTTP status codes are 3-digit responses sent by web server to a browser. They communicate whether a specific request was successfully completed or if an error occurred along the way. These codes are divided into 5 distinct categories based on their first digit. So we have 1XX. Anything that starts with 1 is going to be informational. And these codes indicate that the server received the initial request and the browser should continue waiting or processing. We have 2. Anything that starts with 2 is going to be a success, because these codes confirm that the action requested by the browser was not Bowser from Mario browser was successfully received, understood, and accepted. 3. Anything that starts with 3 is going to be redirection, associated redirection. These codes show that further action needs to be taken by the browser to complete the request, usually because the resource has moved. And then we have 2 more. Anything that starts with 4 is going to be associated with client errors, and these codes mean something went wrong on the user's end, the client side, such as an incorrect URL or lack of permission. Anything that starts with 5 is going to be client error, is going to be server errors. So anything that starts with 4 is client errors. Anything that starts with 5 is going to be associated with server errors. And these codes mean the request was valid, but the server failed to fulfill it due to an internal issue. So hopefully that helps you better understand the different types of status codes. Anything that starts with 1 is going to be associated with informational responses. 2 is going to be success. 3 is going to be redirection. 4 is going to be client errors. And 5 is going to be server errors. So which HTTP status code was returned? It is 200. Bam. And here's our analyst note here as well. To help you better understand the HTTP status code. So HTTP status code 200 means success. Fill in the blanks to count successful web requests to the suspicious domain. So the status code is 200, which is associated with successful. All right, 22. You just trace a single web request across 3 different log sources. Let me explain. Step 1. We use DNS events table to look for domain to IP resolution data. Then we went to network flow. We looked at UDP to DNS server on port 53. Step 3. We used the network flow table as well, but we were looking at TCP to website information, port 443. And finally, we looked at proxy events logs, which is the full URL, which you can see here, and the response, which was 200. So one user action creates multiple log entries across multiple tables. When you're investigating, you need to correlate across all of them to see the full picture. So what happens first when browsing to a website? Is it the DNS lookup, or is it the TCP connection? In this case, it's going to be the DNS lookup, because we can see here that the TCP connection is on step 3, but on step 1, it mentions DNS. So our answer is going to be DNS lookup. Next. So the proxy sees everything that goes through it, including the full URL and not just the domain. So if you use this query, you paste. We're only going to take 5, so we should only see 5 records. Come on. Technology sometimes being wacky. So let me work my troubleshooting magic. Yes, you heard magic. All right, take 5. Boom. So we got our columns. We got source IP, we got URL, we got method, and we got status code. So what column contains the full URL? It's going to be, oh yeah, those are very long URLs. URL, there we go. Nice. So HTTP status codes tell you what happened with a request. We have 200. That's going to be anything associated with OK and success. 301 to 302 and 302. Redirect. 403 is forbidden. 404 is not found. And 500 is server error. So what status code indicates successful request? It's going to be 200. And here's your analyst notes to help you out. So yes, status group codes are grouped by first digit. 1XX, informational. 2XX, success. 3XX, redirection. 4XX, there we go, client error. And 5XX, there's a lot of X's, server error. There you go. In security analysis, watch for unusual patterns, such as lots of 403s might indicate probing. 500s might indicate exploitation attempts. And 302s to unexpected domains might indicate compromise. Bam. So HTTP methods describe what the client is trying to do. We have GET, which is retrieving data, most common for browsing. We have POST, which is submitting data. We have PUT, which is updating data. And we have DELETE, which is removing data. So what HTTP method is used to submit form data? It's going to be POST. And this is going to be the last question for question 3. So let's finish it strong. So you've learned how to trace traffic across DNS, network flow, and proxy events. You understand ports, protocols, and how the network is segmented into zones. You can look at an IP address and know what part of the network it belongs to. This is exactly what Jamie was doing, following traffic patterns, looking for anomalies, building a pattern of what was happening on the network. And that IP from Jamie's note, 185.174.137.42, the one circled twice with "who is this" scrawled next to it, where does it show up in the logs? To learn more or to continue, let's type time to investigate. Nice. We're on to section 4. This is going to be a big one, but don't worry. We can do this. So section 4, the picture emerges. It's going to be fun. All right. The picture emergence. There we go. So Morgan gets pulled away. Again, something about a server error and a volunteer who accidentally unplugged the wrong thing. Can you hold down the fort? I'll be back in an hour. You're alone with the data, Jamie's notes, and biscuits. He was curled up on the warm part of the desk near the monitor. It's time to investigate properly. So let's start where Jamie left off. That suspicious external IP. If anyone connected to 185.174.137.42, they had to look up the domain first. DNS will tell us what domain points to that IP. So we're going to use the DNS events table to look up that domain to figure out what domain points to this IP. And we can see that we got 2. So what domain resolves to 185.174.137.42? It's going to be update-cdn-service.xyz. Booyah! And we have our analyst notes. Always love this. And here's a really helpful tip to help you with your investigations. You can also pivot. No, this is a classic pivoting technique. You start with an IP from logs thread into our notes, and then you use DNS data to find the associated domain. You can also pivot the other direction, start with a suspicious domain, say for example update-cdn-service.xyz, and find what IP it resolves to. Then you search for connections to that IP. Pivoting between IOC types is fundamental to investigation. Yes, it is. Awesome. All right, question 2. The domain that we found in the previous question, which is update-cdn-service.xyz, is not a legitimate CDN. The .xyz top-level domain is cheap and frequently used by attackers because it draws little attention. The name itself is designed to look like boring infrastructure, the kind of thing that wouldn't raise alarms in a casual log review. And this pattern is common for C2, which stands for command and control domains, for command and control, and make it look technical and forgettable. So overall, if you see a .xyz, it looks like boring infrastructure, which wouldn't raise alarms in a casual log review. However, this pattern is actually common for C2 command and control domains because it makes it look technical and forgettable. Let me guess the hint, it's run the query. Oh, it's count the rows. Very nice. Oh, that's awesome. Alright, so we're going to use the domain that we found in the previous question to look for the client IP. And so we're using distinct. So what distinct does is that it removes any duplicates. So if we should only see distinct client IPs. And our question is, how many distinct internal IPs carry this domain? You can see here that there is 3 because there's no duplicates. So the answer here is going to be 3. Nice. All right. Multiple machines are querying this suspicious domain. Let's run our query for this question. We're still using the domain that we found in the previous question, but we're going to try to find the count by client IP. And we're going to order by descending, which is largest number to smallest. So we can see here that each of these IPs belongs to a potentially compromised host. Their DNS queries prove they've been reaching out to the attacker's infrastructure. So, is update-cdn-service.xyz an internal domain, or is it an external domain? So, we know that each of these IPs that we found here belongs to a potentially compromised host. And we can see that the DNS queries prove they've been reaching out to the attacker's infrastructure, and we can see that the domain, this one, is suspicious. So I'm going to say that the answer is going to be external. Nice. All right. Now let's look at the actual network connections. So we're going to go back to the network flow table. If they resolved the domain, they probably connected to it. So we're going to do paste. We're going to use the destination IP that we found previously. And we're going to output the timestamp, source IP, destination port, protocol, and bytes columns. But we're only going to take 10, which means that we're only going to have 10 records as our maximum. This gives me S6, and yes, the hint is from the query. Awesome. All right. So what destination port is this traffic using? So we're going to look at the destination port column, and we can see here it's 443. So that's going to be our answer, 443. Nice. All right, question 5. Port 443 is HTTPS. The attackers are using encrypted web traffic to communicate with compromised machines. From a firewall's perspective, this looks exactly like normal web traffic, like normal web browsing. There we go. Outbound HTTPS to an external server. Nothing unusual about that, which is exactly the point. Attackers choose port 443 because it's almost always allowed through firewalls. So pertaining to this, what protocol normally runs on port 433? You can see here that port 433 is HTTPS. So the answer is going to be HTTPS. That's the answer. And you can see here, using port, how attackers leverage port 443 for C2 command and control activity. Awesome. All right, so let's check the proxy logs for more detail. So we're going to use the proxy events table. We're going to use our domain that we found here. We're going to output the timestamp, source IP, URL method, and status code columns. Then we're going to order by ascending, which means that we're going to sort or order by the oldest timestamp to the newest timestamp. So that way we can see everything that happened at the beginning to the most recent. There we go. So let's look at the URLs being accessed. There's a pattern here. So let's maximize this. What URL path appears repeatedly in this request? We got a hint. Look at the URL column, which we have here. We can see here that for each of these results, we can see that HTTPS, these, update-cdn-service.xyz, API version 1 shows up. So let's type c.xyz AP. Okay, got or. So I'm gonna say they don't want update-cdn-service.xyz from the answer format. So let's try -API version 1. Nice. All right. So they have API v1 status and API v1 config look like legitimate API endpoints, which is intentional, but they're not real API calls. This is C2 beaconing. This is when malware checks in periodically to let the attacker know it's still running and to receive any commands. Status means I'm still here. Any instructions? Config means sending me my configuration. So what does T2 stand for? It stands for, because we found it in a previous question, it was mentioned, I believe it's this one, command and control. So we're going to go to question 7, and we're going to type command and control. Nice. And our analysis notes, it can be found here. Command and control, or C2 or C and C, is how attackers communicate with compromised systems. And identifying and blocking C2 is critical because it severes the attacker's control over compromised hosts. And to learn more about command and control, you can read this analyst notes as well. Let's go here to question 8. When malware contacts its C2 server at regular predictable intervals, it's called beaconing. The infected machine checks in periodically to report status and receive instructions. So common beacon intervals are 5 minutes, 15 minutes, 30 minutes, or 1 hour. And the regularity is what makes it detectable, such as legitimate user browsing is random, but beacons are predictable. So what is the term for malware regularly checking in with its C2 server? It's going to be beaconing. And that is our answer. Yes. And also, it's important to understand this. Beacon detection is a key technique in threat hunting. For instance, analysts look for regular intervals between connections and much more. You can find the information here. And advanced malware uses jitter to randomize intervals slightly, making detection harder. Thus, statistical analysis can still detect this. Okay, Morgan texts you. Server issue is more complicated than expected. Might be another hour, huh? You okay? You look at the screen, 3 compromised machines, C2 traffic, active beaconing. You're not okay, but that's not what he texts back. Let's type all good here to continue. Here we go. Alright. Let's trace the attack chain. Where did this start? Most compromises begin with phishing, so since you mentioned phishing, we're going to use the email table. So we're going to use this query. And to break this down, we're looking for indie senders email addresses that doesn't end with whiskers@wonders.org, but we're looking for indie sender email address that contains whiskers and wonders, and we're going to output the timestamp, sender, recipient, and subject columns. There you go, not tables. So what domain in the sender address is impersonating the sanctuary? It is going, so we're looking at sender address, so we're going to look at domain. We can see here that there's a domain. It's going to be whiskersandwonders-hr.com. So let's type that as our answer. It's whiskersandwonders-hr.com. Nice. Alright. The domain whiskersandwonders-hr.com is not whiskersandwonders.org. Someone registered a lookalike domain and sent emails pretending to be HR. Classic credential phishing. So we're still going to use our email table. We're going to change the query up a little bit. And we're going to look for, now we're going to use this suspicious domain that we found, whiskersandwonders-hr.com. But we're still going to output the same columns, timestamp, sender, recipient, and subject. Define the subject line. It's going to be external, important, employee, benefits, update, required. Nice. All right. The subject line employee benefits update required with an urgency marker is textbook social engineering. Create pressure. Impersonate authority. Get people to click before they think. So we're still going to use this email. There we go. We'll use this key. Now we're going to find the recipient. So we're going to figure out how many employees received the phishing email. Then we're going to count. And our hint is to count the distinct recipients. So we see here, we got 3. So 3 employees received a phishing email from our suspicious domain. So the answer is going to be 3. Give me one moment, please. All right. Moving on to the next question, which is question 13. We see here that there is 3 phishing targets. Multiple machines carrying the C2 domain. That's not a coincidence. That's verifying. The employees who received the phishing emails should be the ones whose machines are now beaconing. So now let's use these queries. And also there's really great comments as well. So for this query with email, we are getting the phishing recipients. We're getting information about who received the phishing email. With that information, we're going to then use this query, which has the DNS events, which is using the DNS events table to compare to C2 DNS queries. So, our question is asking us, did all 3 phishing recipients become compromised? Yes or no? So now that we got the phishing recipients, let's compare this to our C2 DNS queries. Let's click on run. And we can see here that the client IPs have been mentioned, so I'm going to say this is yes. And also here's a helpful hint. We're going to verify that the employees who clicked phishing links are the ones with C2 activity. We're going to cross-reference the phishing email recipients with the hosts making C2 connections. If they match, answer confirms the connection. So indeed, yes. So I'm going to say it's going to be yes. Nice. All right, question 14. The attack chain is clear now. First, the attacker registered a fake HR domain, sent phishing emails to targeted employees, and they clicked. Malware installed on their machines and began beaconing to our suspicious domain, update-cdn-service.xyz over port 403, blending in with normal HTTPS traffic. Jamie found this. That's why the notes were so urgent. That's why they left. Type, Jamie was right. Good job, Jamie. Next. All right, so we got 15 to 33. We got this. All right, so let's build a timeline. When did the phishing emails arrive? So we're starting off with what happened first. The attacker registered a fake HR domain, then they sent phishing emails to targeted employees. So we're going to figure out when did these phishing emails arrive using this query, where we look for any emails that were sent to employees. Then we're going to use the timestamp and recipient columns, and then we're going to order by timestamp of sending, which means the oldest timestamp to the most recent. All right. So what date was the first phishing email sent? You can copy and paste it. Awesome. So we're going to do 2025. Okay, so I can type. So I can do, let me see, 6/2/2025, 16. Hopefully I don't get flagged by a format. Did I get flagged? What's happening? 6. When did the first email? Let me see something. 1/16. What date was the first email? 6. to 2025. And then good. Oh, we want the 0, 0. Okay, I got you. So let's do this. Let's do. Okay, you want to play like that? Let's do that. Let's do 0, 0. 0, 0. And then it should be. There we go. Nice. Persistence. There we go. Now, when did the C2 traffic start? So now we're going to look at C2 traffic. So transitioning to our DNS events table, we're going to use this query. Base. So what this query does is that we're looking for any queries that contains update-cdn-servers.xyz. Then we're going to try to find the first query by the min timestamp, or think of it as like ascending order where we're looking at the oldest timestamp. That's what min timestamp is. We're looking for the oldest timestamp by client IP, and then we're going to order by first query ascending. So what this will do is that we're going to try to figure out how many hours between the phishing email, which we found was at 16, and the first C2 beginning. So our hint is that we're going to count how many emails the employee received during a specified time frame. We're going to filter the email table for the recipient's email address and the date range, and we're going to add count. So we got 06/62 2025 4 p.m. This looks like it is going to be 11 p.m. 23. So let's do 7. Bam. We're good with math. There we go. Awesome. So what I did was that I looked at the date and the time for when the first phishing email was sent, which was 6/2/2025 at 4 p.m. And then I took basically this, I converted it to just regular time because it's in military time, so 24 hours. So 23:52:31 is going to be 11:52:31. 11 minus 4 is 7, and that's what I put around, and that's what I put as my answer. Or you could have put less than 8 or less than 10, and that is how you would get your answer. And we already covered analysis notes, and a hint is compare the timestamps, which we did. Awesome. All right. Question 17. First, we saw the beacon activity in the DNS events table. As the compromised computer tried to resolve the malicious domain, now we see the compromised computer having web requests to the malicious domain. So we're going to look at proxy events so that way we can see the web requests to the malicious domain. And with this information, we're going to try to figure out how many requests did the victim computer make to the malicious domain. And from our data and output, we can see that there's 6 records. So I'm going to say that there's 6 requests. Nice. All right. Now let's build the full IOC indicator of compromise list. So let's break down this so that we can find our C2 domain. So first, we found that there was a malicious domain, which is update-cdn-servers.xyz using the DNS events table. Then we try to find malicious IP. So let me run this to help you better understand what I'm talking about. To find the malicious domain. Then we're going to try to find malicious IPs. We're going to find any IPs associated with update-cdn-servers.xyz, and more specifically, resolved IPs. And we're using toString to convert because resolved IPs is an int to string. And that's where we found our resolved IP 185.174.137.42. And then we found our phishing domain, which is where sender contains whiskers and wonders.hr. And this is our phishing domain sender. So what is the C2 domain? It is going to be update-cdn-service.xyz. Awesome. So what is the C2 IP address? It is going to be 185.174.137.42. Awesome. What is the 13 sender domain? Alright, let's run this query. It's going to be Whiskers and Wonders -hr.com. Nice. And what destination port is the C2 traffic using? Well, let's look at proxy events. I believe it is going to be in here. Or it could be in DNS events. I remember it's going to be in DNS events, so let's look at... let me see if I can... Let's see if I can bring up... Come on. There we go. Give me my scroll. Not this one. This one, there we go. About tables, DNS events. Give me my port. Looking for a port. User zone is cached. Email. Proxy events. Source port. So we're going to look at proxy events. And we're going to look for our port. So we're going to use this. We found our malicious domain, so we're going to try to find the port associated with it, which is our, this is our C2 domain, so we're going to try to find the port. So we're going to do this. We're going to source port. I'm just going to add destination port just in case. Oh, good. There's only source port. So we should get our port. And I believe it is going to be O. Okay. So for this question, I believe it is going to, let's try your network flow. 443. There you go. So, to break that down, how I got it, we use the network flow table and we use the C2 IP to find the destination port of the C2 traffic, which is 443. Analysis notes are here. Look at the destination port and outbound network events. In this case, it's going to be network flow. For the C2 connections, the attacker is using a common port for the command and control channel. It's likely going to be HTTPS 443 or HTTP or port 80. Now let's find out who was specifically compromised. So we're going to use this query to compare to C2 queries, and we're going to join the inner table. We're going to use the employees table as well. So what we're going to do, let me break down this query. If technology works. You didn't see that? So what we're going to do, there we go, is that we're looking for any queries associated with our C2 domain, and we're outputting the distinct client IP, but we are joining with the employees table, so that way we also output or use or leverage employee columns in the employees table, such as IP address, name, username, and role. And this is how we joined. We use the client IP column in the DNS events table to join with the IP address column in the employees table. And then once we have that, we then output the name, username, and role columns. So that way we have that information. And so what is the name of the compromised development officer? Well, we found the role, development officer, and the name is Alex Revere. Okay, so next, So still using this query, what role do two of the compromised users share? We can see here that two of the users have the same role, which is going to be adoption coordinator. Nice. All right, so look at who got targeted. A development officer who handles donor relationships, and adoption coordinators who have access to donor and adopter data. This wasn't random. The attacker went after people with access to the donation system. In Whiskermania, the big fundraiser is in 5 days. To continue, let's type, they want the money. And now let's think about remediation from a network perspective. To stop this attack, you need to block the C2 communication. There are multiple points where you can do this. First is the DNS level. You can block the domain lookup so the malware can resolve the C2 address. You can also use the firewall level on multiple points. At the firewall level, you can block the IP address directly. And at the proxy level, you can block the URL pattern. So what domain should be blocked at DNS is going to be update-cdn-service.xyz. Nice. And yes, defense in depth means blocking at multiple layers. In this case, we're thinking of remediation from a network perspective. So we're thinking of the multiple ways in which we can do remediation, such as leveraging the DNS level, firewall level, and proxy level, and implementing blocks. So that would be stop the attack and overall block the C2 communication. So now at the firewall level, what IP address should be blocked at the firewall? It is going to be 185.174.137.42. And what URL path pattern should be blocked at the proxy? So we use a different query. It's this one. There we go. URL pattern API v1. Analyst notes here. The C2 traffic uses a specific URL path pattern. Look at the URLs in the malicious network connections and identify the common API path that should be blocked, like API version or API v1, which we found using this query here. And then let's write detection rules based on what we learned. And our question is, what table should you query to detect C2 domain lookups? And for analyst notes, detection rules should be specific enough to minimize false positives, but general enough to catch variance. And also, these rules should be tested against historical data before deployment. So we're going to run this query. And you can see here, detection 1, we are detecting for any DNS queries to a known C2. The C2 domain is update-cdn-service.xyz. Detection 2 is that we're looking for any traffic to a C2 IP, which we found, which was 185.174.137.42. And finally, we're looking for any proxy pattern matching any logs associated with -API and any domains that ends with .xyz. So, with this information, what table should you query to detect C2 domain lookups? It is going to be DNS events. And what table should you query to detect network connections to C2 IP? Could be network flow. And what table should you query to detect the API v1 status beaconing pattern? It's going to be proxy events. And now we've mapped the entire attack chain from a network view. We start off with a phishing email. We use the email table. Then we looked for any user click events. And then we looked for any malware install events using the file creation process events tables. And then finally, we looked at any C2 beaconing events. We used the DNS events, network flow, and proxy events table. Every step left traces in the network logs. That's how you found it. And that's how Jamie found it. Type almost there to continue. Almost there. So let's build a final summary of the timeline. Don't worry, I'm going to help break down this query because it looks very big. But what this query does is that it shows when each compromised host started beaconing and how many times they've checked in. So with this query, approximately how many days has the C2 been active? And we got a hint, subtract the first beacon, which is going to be the oldest timestamp, from the newest timestamp, which is last beacon. We're going to run this. So basically what this does is that it shows us the compromised hosts, when they first started beaconing, and how many times they checked in. So approximately how many days has the C2 been active? We can see that they started beaconing. The first compromised host started beaconing on June 2nd, 2025. And then we saw that the last entry was at June 7th, 2025. So I'm going to say it's 5 days. And here is our case summary. Overall, how would we document this incident? We've uncovered what Jamie couldn't finish investigating. We have an attack summary. How did the attacker gain initial access? They gained initial access via phishing via whiskersandwonders-hr.com. The targets were 3 employees with donation system access. We had a C2 domain, which is update-cdn-servers.xyz. We have a C2 IP, which is 185.174.137.42. We have a port, which is 443. And the duration was around 4 days active. And the indicators compromise we can leverage in our security tools to block is DNS. At the DNS level, update-cdn-servers.xyz. Our malicious IP is going to be 185.174.482. And at the proxy level, look for any patterns with API v1 status or API v1 config. The recommended actions are to block the C2 domain at DNS, block the C2 IP at firewall, block URL patterns at proxy, isolate compromised hosts, which in this case is going to be 3 of them, and reset the credentials for affected users. Morgan stares at the screen. We need to tell someone, the board, maybe law enforcement, definitely you say. And Jamie, Morgan pauses. Should we tell Jamie what you found? You look at the post-it notes, the cold coffee, biscuits still asleep on the desk, completely unbothered by the crisis you just uncovered. I think Jamie already knows. That's why they left us the breadcrumbs. And type, thank you, Jamie, to complete the investigation. And also for doing post-incident reporting. The steps would be usually forensic imaging of compromised hosts, password resets, reviewing donation transactions for fraud, notifying donors if PI, personally identifiable information, was potentially accessed, engage in incident response and legal counsel, and filing an FBI IC3 report. For nonprofits, cyber insurance and pro bono incident response services may be available. So let's type, thank you, Jamie. And congratulations, we have completed the Whiskermania room. I've already completed this room, so that's why you're going to see the replay complete. But just know, if you do complete this room for the first time, hopefully that was a very beneficial and overall fun experience. And hopefully you've enjoyed my walkthrough of Whiskermania. And overall, I hope you found this walkthrough very helpful. I will see you guys in the next one. Peace.